Alright, welcome to today's video. Today's video is on proving similar triangles. So, what does it mean that we have similar triangles? It means basically they have the same shape, but different sizes. So, here we go. Two triangles that look similar. If they're similar, what would actually have to be true? Well, first off, all of their angles, when you match them up, would be equal. Also, all the sides are proportional, which means that they have the same scale factor. Alright, so first off, let's take a look at the angles. How would we write that the angles are equal? So we'd write angle A equals angle D. You can see they both have that single mark on them. Angle B equals angle E with the double mark, and then angle C equals angle F. So that's how you would write out that all the angles are equal. It's a little more involved to show that the sides are all proportional. So what we got to do here is set up fractions, because you might remember that proportion just means that you're saying fractions are equal. So if we match up these sides, we got AB matching up with DE. And so we're going to put AB over DE, and that's equal to BC matches up with EF, and then AC matches up with DF. Notice when I talk about sides, if you trace from one letter to the next, when I say side AB, if you trace from A to B, that's the side I'm talking about. So you always have to have the right order when you put these things together. So I like to stick with the same order each time. I go ahead and put the side from the small triangle over the side from the large triangle. And how do you know that AB matches up with DE? Look at the angle markings. A is angle 1, the way it's marked, and B is angle 2. And then when you look at DE, we're going from angle 1 to angle 2, and it follows for the rest of them. So those are the sides that are proportional. And then I can prove that they're proportional by putting in the numbers that we have. So we got 6 over 18, which is equal to 7 over 21, which is equal to 8 over 24. All three of those ratios reduce to 1/3. So those are all the things that would happen when you have these two similar triangles. So if you have similar triangles, they would have 3 pairs of angles that are equal and 3 pairs of sides that are proportional. But in order to prove that you have similar triangles, you don't actually have to prove all 6 of those things. It turns out that it just takes 2 or 3 things to prove that you have similar triangles. So the first one we got is called angle-angle similarity. So as you look at that drawing, if you've got 2 angles or 3 angles that are marked equal, that's enough to say these 2 triangles are similar. You can also call it angle-angle-angle similarity. The reason why you only need 2 is if 2 of the angles are equal, the third angles would have to be the same because of triangle equals 180. All right, the second way that you would say that triangles are similar would be side-side-side similarity. So this means that when you match up all 3 corresponding sides, your ratios are going to be the same, which means all the sides are going to be proportional. The final way that we can use to prove that we have similar triangles is side-angle side similarity. This means that you have 2 sides that are proportional, and the angle has to be in the middle of these 2 sides. The angle in between the 2 sides that you can see here, that's also called the included angle. So that concludes our 3 ways to prove that triangles are similar. So we're going to take a look at some specific examples on how we use these 3 different ways to show that triangles are in fact similar. We'll start with angle-angle similarity. So you can see our problem here, and you've got some given information. That AB, that symbol in between AB and CD, that's the symbol for parallel. So we're given that AB is parallel to CD. So let's go ahead and just copy paste an example here, and then we'll work on our copy. Actually, I don't even know why I did that. Unnecessary. Actually, you know what I guess I'm doing is I'm showing off my virtual whiteboard app. Isn't it amazing how it actually looks like it's a real whiteboard? Plus, on top of that, the copy-paste function humanizes the effect. So if you look carefully, that copy that I made, it's actually a little off because they've humanized the effect. You know, it's amazing. The little things they do in technology today sometimes just blows your mind. All right, moving on to the problem. So as you can see, I've marked the AB and CD segments with the green arrow. So the green arrow, that's just showing that those two segments are parallel to each other. So the question is, if those are parallel, what kind of angles can we then say are equal? Do you see like a Z and a backwards Z? So like if you go from A to B to D to C, that would be a Z. And if you go from B to A to C to D, it's a backwards Z. So we have a name for those types of angles, and they're only equal when you have the parallel lines. You remember what they're called? Let's go ahead and mark them first. So those angles, you might remember, are called alternate interior angles. So now we can go ahead and write out what we've got so far. We've got angle A is equal to angle C, angle B is equal to angle D, and the reason is alternate interior angles are equal. All right, we could stop right now and say, hey, we've done enough, we've proven angle-angle similarity. But just to show you, you do have another option here. Since AC intersects with BD, that gives you some more equal angles. So let's go ahead and mark those. All right, so those angles that I just marked, those are called vertical angles. So now we can write down a third pair of angles that are equal. So angle AEB is equal to angle CED because they're vertical angles. Notice on this one I actually used 3 letters to describe the angles. That's because at point E, there's multiple angles available, so you got to trace it using 3 letters. Our final step is to go ahead and write out what we've proven exactly and what the reason is. So we're going to write triangle AEB is similar to triangle CED by angle-angle similarity. Now there's a whole lot of options you can use in terms of the order for your triangles that work, but the key is whatever you choose, A and C have to be in the same position, the E's have to be in the same position, and B and D have to be in the same position. I went ahead and just, when I did vertical angles, I followed the same order. If you look at AEB and CED, notice that I went from angle 1, the way it's marked, to angle 3 to angle 2. Okay, so as long as you follow the same order, then it's a correct way to say that they're similar. Let's go ahead and take a look at another example that uses angle-angle similarity to prove that you have 2 similar triangles. All right, so notice that in this one, the given information that AE is parallel to BD. Let's start by marking that. So now the next question is, what angles are going to be equal because we have those parallel lines? In this case, you don't have like a Z going on. There's no alternate interior. This time, you've got what are called corresponding angles that are equal. So let's go ahead and I'm going to separate the triangles and go ahead and mark those angles. So let's write down what we've got so far. We've got angle CBD on the left in the small triangle is equal to angle CAE also on the left on the big triangle. And then going the other direction, we've got angle CDB is equal to angle CEA, and the reason is their corresponding angles. Now again, we've proven enough, we could stop right there and say we proved angle-angle similarity. What about that third angle? Do you notice something about that? In both triangles, the third angle is the same angle. So clearly, angle C is the same thing as angle C. And what we called that, it's a shared angle, and you can also call that, the official term is reflexive property. So let's go ahead and write that. And then our last step is to go ahead and write out the triangles. I'm going to choose triangle CBD is similar to triangle CAE by angle-angle similarity. Next, we're going to go ahead and use side-side-side similarity to prove that we've got similar triangles. So one thing that can be helpful for you is doing some sort of markings so that you're clear on which sides definitely match up with which sides. So we're going to match up the shortest side on the triangle on the left and the shortest side on the triangle on the right. So that would be 4 on the left and 6 on the right. Let's go ahead and circle those. Then you can take a look at, well, which is the longest side for both triangles? And on the left side, 8 is the longest side, and on the right side, the 12 is the longest side. So now we can go ahead and underline those sides. And you don't need to do anything with the third side. We'll just call that the blank side. So we got circle sides, underline sides, and blank side. So now we can go about writing our proportion. So we'll go with AB over EF, the matching circle sides, has to be equal to BC over AFD. Those are the blank sides. And that is equal to AC over ED. And so there's our proportion. Now to prove that that proportion is true, we'll go ahead and insert all the numbers. So we get 4 over 6 equals 6 over 9 equals 8 over 12, and all of those reduced to 2/3. Last step, go ahead and write out the triangles. Triangle ABC is similar to triangle EFD by side-side similarity. Let's look at another example that uses side-side-side similarity. We've got overlapping triangles again, but this time instead of having AC and DE being parallel, we're given a bunch of side lengths. When you're given a bunch of side lengths, it's pretty important to go ahead and redraw them as two separate triangles. I even think it's useful to go ahead and label the small one and the large one. This helps us later when we try to get things in the right order. Let's go ahead and label the side lengths of our small triangle. Now realize on the large triangle, you can't just copy numbers that you have. And this is why I like to make it clear that we have a small triangle and a large triangle. The distance from A to B is definitely not 2. But take a look, I think you can know what it is. It's going to be 2 plus 6. So the key here is those sides on the left and the right, you need to add the numbers. So let's go ahead and add those now. Alright, so next up, we can start proving that we've got side-side-side similarity. So let's match up our sides in a proportion. So we've got DB over AB is equal to BE over BC, which is equal to DE over AC. And then to prove that that's true, we'll go ahead and add our numbers. 6 over 8 equals 9 over 12 equals 12 over 16. Those all reduce to 3/4. And our last step, go ahead and write triangle DBE is similar to triangle ABC by side-side-side similarity. Our last way to prove similar triangles is side-angle side similarity. So this problem actually looks just like the last problem we did, except we don't have the measurement for DE and AC, so we can't do side-side-side similarity. It's still a good idea to go ahead and separate the triangles, small and large, and label what we've got. Do you know what AB is going to be? Got to add for AB and BC. So let's mark that. And now let's go about proving that we have two sides proportional. So DB on the small triangle matches up with AB on the large triangle, and that's equal to BE over BC. To prove it, we'll add in our numbers. 6 over 8 equals 9 over 12, which reduces to 3/4. Now, we need to prove that the included angle is equal. And the included angle in this one is angle B in both triangles. So angle B is going to be equal to itself, and we recall this reflexive. Last step, we'll write that triangle DBE is similar to triangle ABC by side-angle side similarity. Last example, so if this is going to work for side-angle side, I would know that the 10, the smallest number on the top, would have to match up with the 15, the smallest number on the bottom. So let's go ahead and mark those, and then let's go ahead and prove that our sides are proportional. So BC would match up with DC, and that would be equal to AC over EC. Put in our numbers, we get 10 over 15 equals 14 over 21, which reduces to 2/3. Now, how about angles? This time we've got vertical angles that are equal. So let's go ahead and mark those, and now we can write them out. Angle ACB is equal to angle ECD because they're vertical angles. Last step, write out that triangle ACB is similar to triangle ECD by side-angle side similarity. Time for some practice problems. So remember, go ahead and hit pause when you see the problem, work it out on some scratch paper, and then hit play to check your answer. So hopefully you realize that the drawing looks a little crooked. That's actually on purpose. The line from A to D is not one straight line, and same thing from B to E. So you don't actually have vertical angles that you can mark. Alright, so here's some useful marks you could have made, and here's the answer. Mark your given information first, next your corresponding angles, and here's your answer. Some useful markings, and here's your answer. Alright, that concludes the video. Remember, you can always come back and skip straight to the practice problems to see if you still remember what to do. Thanks.